Hello everyone. Two blocks of mass M1 and M2 are accelerated together by a rope attached to M2. If both blocks are accelerated to the right, what is the direction of the frictional force on each block? Assume the frictional force between M1 and the surface is sliding on is 0, but there's friction between M1 and M2. So basically this is just saying draw a free body diagram, figure out what's going on. Okay? Now, I'm going to work it again a little bit, and I'm going to add some masses to this and a coefficient of friction so we can actually find the friction force between the two. But right now, let's just draw some free bodies so we know what's going on. Why not add masses? So let's say M1 is 5 kilograms. M2 is 20. Okay? So M2 is 20 kilograms. And there's no friction between M2 and the floor. I'm going to leave it at that. But let's say the coefficient of static friction is 0.2 between the boxes. Okay. Theory-wise, this problem isn't too hard, but let's do some math to this. All right? And let's say the tension in the rope is 80 newtons. That way we know the thing's going to move. It's going to accelerate. Okay? And it says accelerated, so I want it to accelerate. Now, the first thing we got to do is find that acceleration, and the best way to do that is to work through both boxes combined. In other words, let's come in here and make it 25 kilograms. Let's do our free body and work through that. Okay? So mg going down will be 25 times 9.8. Let's find out what that is. It's 245. We have a tension going this way of 80 newtons. We have a normal force. And that's it. There's no friction. Okay? The only other thing we have is we have an acceleration this way. All right, now, first step's free body. Second step is friction. Second step is components. There's no angle, so no components. So I'm going to the third step, sum of the forces on the y. MA equals up minus down. There's no acceleration up and down, so 0 equals normal minus 245. So my normal force equals 245. Now, some of you are probably sitting here thinking, but I don't need to do these steps. You're correct. Some of these steps don't need to be done. But what I'm doing here is going through the steps blindly. I'm just always following those same steps. Because if I always follow those same steps, I get a solution. Regardless. So let's just blindly follow the steps. Let's get an answer. There is no friction, so I can skip the friction step. So I do the sum of the forces in the x is MA equals right minus left. So 25A equals 80, and there's nothing to the left, so we solve that for our acceleration, which is going to be 80 divided by 25. So in Mr. Calculator, I get 3.2 for A. Now both boxes are undergoing that acceleration, so no matter what I do, no matter which picture I draw, I'm going to deal with that. Okay? Now, I can draw box 1 or I can draw box 2 for the next part. It doesn't matter which box you pick because according to Newton, the forces between the boxes are equal but opposite. They're equal in value but opposite in direction. Okay? So, I think I'll pick M1 because M1 is the lighter box. And remember, this is 5 kilograms. So what are the forces on this box? We have a normal force going up. We have mg going down. This box is accelerating this way. No matter what, they're both moving the same direction. And this acceleration here is 3.2. Now, which way does this box want to move? It wants to move that way. Actually, no. Which way does it want to move? Because it's sitting on top of the other box. So if I use this as one box, I'm trying to find something similar to a box here. This will work. So if you use these as boxes and they're moving this way, well, according to the top box, when I move the bottom box, it wants to go backwards. Okay, I know this is simplified, but if I were to do it here, you can see it. It still wants to move back according to the bottom box. Okay, if I turn this where it has some friction. It does stay with it, but it still moves backwards. Friction opposes motion, so friction will go this way. Okay, so friction's to the right for M1, and equal and opposite, so friction will be to the left for M2. Okay, so the correct answer to this one is D, right for M1, left for M2. But we're working the problem out. So now we're going to do some of the forces in the Y. It's MA equals up minus down. This is not accelerating up and down, so it'll be 0 equals going up, I have my normal force, minus, and I didn't do mg, that's 5 times 9.8, and that comes out to be 49. So minus 49, and I get my normal force equals 49. And then I can do friction equals mu times the normal force. And I wrote the coefficient of friction as 0.2 way back up here. Okay, so 0.2 times 49 will give me my friction force. Okay, and I get 9.8. Or I can go through and do some of the forces in the X. That's MA equals right minus left. So 5 times 3.2 equals friction. 5 times 3.2, let me get this right on the calculator, comes out to be 16. Alright, so which ones were correct? Is the friction 9.8 or is the friction 16? Which one's correct? Okay. Well, we need to discuss this because there's a contradiction here. The acceleration requires friction to be 16 to keep it in place because it's static. All right. But friction due to the weight of the box is 9.8. Okay. So my friction force due to the acceleration is greater than the friction force due to static. So this thing isn't going to hold in place. It's going to accelerate, and this acceleration is going to be wrong. Okay? So the box will move. It's not going to be static, so I can't use static friction. But this just goes to illustrate that the calculated friction isn't always equal to the actual friction required for it to be stationary. And when that happens, we have to make a decision. Is the box moving or is the box stationary? In the case of this one, the box is going to move. Now the friction force is still in the direction shown, so we didn't get this part wrong up here. Okay? And this is a theory question, which makes it a little bit easier. I just wanted to work through this and add some math so everyone could see some math when we have to work these.